Okay, so let's take a look at another electromagnetics question. Here we're told two current-carrying wires hang 1 centimeter apart. The first has 1 amp of current upwards, the second has 2 amps of current downwards. A, find the force per unit length. Okay, so we'll draw a diagram of these two wires. We have one wire here, we have one wire here. We're assuming they're hanging. One of them has 1 amp of current upwards. So this one, the current goes up. This is 1 amp. The second has 2 amps of current downwards. So this current goes down, and this is 2 amps. Find the force per unit length. Okay, so in this case, the formula we're going to be using is force per unit length. So force per unit length formula is mu naught over 2 pi multiplied by current 1 times current 2 in the numerator, multiplied by radius in the denominator. So radius is the distance between the two cables. Now they're 1 centimeter apart. This is 0.01 meters. So that's this distance here. So that's R. We have current 1. I1 is 1 amp. We have current 2. I2 is 2 amps. We know mu naught. Mu naught is the permeability of free space constant, not to be confused with the permeativity of free space, and it has an approximate value of 4 pi times 10 to the minus 7. So we have everything. We just plug these all in. So this implies force per unit length is 4 pi times 10 to the minus 7 times 1 times 2 divided by 2 times pi times 0.01. So this 2 and this 4, we can simplify. The 2 pi's cancel. So now we'll plug this all into, plug what's left into the calculator. We've got 2 times 10 to the minus 7 times 1 times 2 divided by 0.01. My calculator tells me this is 4 times 10 to the power of minus 5, and this will be in terms of newtons per meter. And this is the answer to part A. Now part B asks us, would the answer change if the currents swapped? The answer is no. No. We could exchange I1 and I2 in this particular arrangement. Because we have currents going in opposite directions, one's going up, one's going down, we know that they are repulsive. They're going to repel one another. It doesn't matter which one is 1 amp or which one is 2 amp, the force of repulsion will be the same. So for B, no. Force will stay the same. Stay the same if we swap them, this is the answer to part B. And then part C, would the answer change if the direction of one of the currents changed? This is a little bit more complicated. The answer is yes. The magnitude will not change. If one of them changed direction, they would then be in the same direction, they would then be attractive. So would the answer change? Technically yes. Yes. If one current direction changes, the force will become attractive as opposed to repulsive. So this force here, this is a force of 4 times 10 to the minus 5 newtons, and it is a repulsive force. It is repelling the two. If we change the direction of just one of them, it will turn it into an attractive force. It will then attract the two cables.